In the previous videos, we looked at finding the units digit or ones digit of this number, and then finding the remainder of this number divided by 4. And we saw that we were hunting for patterns, which was a pretty cool and powerful strategy. So let's see how far we can take it. What if we're presented with this monstrous problem, this whole thing divided by 3, and we want to know the remainder? So this part of it looks like that, where maybe we can hunt for a pattern, but then there's these plus and minuses, and then it seems like we may just have to multiply this. And I don't know about you guys, but I'm pretty lazy. So this topic will be a lazy man's dream. It'll be it's awesome. So anytime you have a divisibility, remainder problem, anything like that, you might want to think of, can we use mods on it? So what are mods? So let's say you want to do 15 divided by 7, which is 2, remainder 1. So in mod notation, we're going to say 15, and we use these 3 equal signs, is congruent to. So we don't say equals, congruent to 1 mod 7. So what does this mean? This means when 15 is divided by 7, it leaves the same remainder as when 1 is divided by 7, which happens to be 1. So I like to think of these as islands. So when you divide by 7, your possible remainders are 0 through 6, right? If it's a remainder of 7, it's actually just 0. So 7 divided by 7 leaves a remainder of 0, so you're always in this range. So what else leaves the same remainder as 15 and 1? Well, 8, right? 8 divided by 7 also leaves a remainder of 1. How about 22? So how about 29? So you notice, if we keep adding 7s, we're going to stay in the same remainder, the same set of islands. It's all going to be a remainder of 1. But we could subtract 7, so we could go minus 7, minus 7, minus 7, minus 7. 1 minus 7 is negative 6. Negative 6 minus 7 is negative 13. So all of these have the same remainders. So you might be wondering, what's with these negative numbers? Well, let's look at this really quickly. How can you have a negative remainder? So let's say we're doing 22 divided by 7. Well, that would be 3 remainder 1. That's the way we're taught traditionally. But we could say it's 4. What is that? So 7 times 4 is 28, but we overshot it, so it's actually a remainder of negative 6. So that's how you can get a negative remainder. Now, we tend not to think about it this way because it doesn't make much sense. So if you're dealing with physical things, I have 22 apples, I have 7 students, each student gets 3 apples, there's 1 left over. I can't say, hey, each of you gets 4, but now there's I've allocated too much, so give me 6 back. You can't give people imaginary apples. So we tend to think of it in this forward or positive direction, but in math, you can think of it abstractly. You can go negative. All right. And there'll be a reason why we're interested in these negatives, so stay tuned for that. So the whole idea of mods will be taking crazy looking things, large things like this, and shrinking them down. So let's say we want to find 15 squared mod 7. In other words, the question we're asking is, what is the remainder when 15 squared is divided by 7? So traditionally, you would say, okay, I have to calculate this. That's 225. Divide that by 7. That's going to be 210 plus another 14. So it's 224 plus 1. And then the remainder is going to be 1. So the answer should be 1. So the question is, can we get this one in an easier way than actually squaring this and dividing by 7? So let's think about what a 15 is. 15 is really 14 plus 1 because that's the remainder when you divide by 7. So rather than squaring 15, we're going to break it down this way. So when we square this, we're squaring 14 plus 1, which is 14 plus 1 times 14 plus 1. And now we're going to expand this. So we go 1, 2, 3, 4. All right, so if you notice, 1, 2, 3, 4, all the terms have 14s in them other than this last one. That's not an accident because the 14s are traveling all over the place. But here's the thing, when we're dividing by 7, these 14s if you just focus here, they're going to give you a remainder of 0. So we're not interested in zeros. They're obvious, they're easy, so we just throw them out. This might resemble the divisibility by 3 proof or by 9 proof from way back when in the previous videos. So you may want to refer to that. This is the same idea. So we're going to throw this out, throw this out, throw this out. Why? Why are we throwing it out? Because they're not interesting. These are divisible by 7. The only interesting part is this last part, which somehow looks like a smiley face. All right. So the idea is this. Rather than squaring the 15, here's the takeaway from this video. Don't square the 15. Replace your 15 with a 1, because that's what 15 is mod 7, and then square the 1. So would you rather do 15 squared, or would you rather do 1 times 1? So 1 times 1 is 1. That's how you get this. So let's try a few quick examples to get the hang of it. So what that was the justification of why this is going to work. So let's do a similar problem. So 16 squared, and we're interested in mod 15, let's say. All right. So what is 16? We could square 16. We're not going to do that. So we're going to replace 16 with a 1, because 16 leaves a remainder of 1 when divided by 15. So rather than doing this problem, we're just going to do 1 squared, and we're done. That's your answer. So 16 squared divided by 15 leaves this remainder. So let's say this were mod 14, so it's a little trickier. So what is 16 divided by 14? The remainder is 2. So we're going to replace the 16 with the 2, and then instead of squaring the 16, we're going to square the 2. So what's 2 squared? That's 4, and 4 is in the 0 through 13 range, so we're done. That's it. That's all there is to it. Let's say this is 16 to the 5th power, so a little slightly scarier problem. So again, we're going to replace it with a 2, and instead of doing this, we're going to do 2 to the 5th. So 2 times 2 is 4. That's 2, sorry, yeah, we have 2. So we have 2 to the 1st, 2 to the 2nd, 3rd, 4th, 5th. So we have 2, 4, 8, 16, 32. I'm counting the powers of 2 here. So this is really 32. And 32 divided by 14 leaves a remainder of 4. It's 28 plus 4. So the answer is 4. Now, would you rather raise 16 to the 5th power or multiply 2 to the 5th power? Now we can do better yet, because we don't actually have to even get to 32. We could just work our way here. So 2 to the 5th is going to be, like we said, 2, 4, 8, 16. But whoa, 16, we could already shrink that back again. That's just a 2. So instead of doing 16 times 2, we're going to do 2 times 2 and get 4. So the idea of mods is we take things and we shrink them down first, and then we do stuff with them. Now, don't get too much into this point, but to be complete, I want to mention this. You can do plus, minus, times. You have to be very careful with division. So unless you know what you're doing, this is a little bit beyond the scope of what we're doing. Just assume you can't do division unless you know what you're doing. What do I mean by division? So you can do any operation. So let's say if 2 leaves the same remainder as 5, mod 3, meaning 2 divided by 3 leaves a remainder of 2, 5 divided by 3 also leaves a remainder of 2, hence they're congruent with respect to mod 3, with division by 3. So let's say I have another statement like, well, 3 is the same or congruent to 6, which they're both actually equal. We can reduce this to 0. 3 divided by 3 leaves a remainder of 0. 6 divided by 3 leaves a remainder of 0. Hence, when we say congruent, this means they have the same remainder when divided by 3. So we could say, hey, this is true, that's true, let's add them. So 5 leaves the same remainder as 11 mod 3. Is this true? Yep. If we move in 3s from 5, we hit 11. So they're on the same island. So that's what I mean by plus. We've added these two conditions. Now you could add it to itself. So 2 plus 2 better be congruent to 5 plus 5. So is 4 congruent to 9? 5 plus 5 is 10. Is 4 the same as 10 mod 3? Yes, it is. 4 plus 3 gets you to 10. So that's what I mean by plus is fine. Subtraction is fine. Multiplication is fine. So you could multiply both of these by any number you want. Let's say by 7. So by any whole number. So this would be 14, and this times 7 will be 35. And this is still a true statement because 14 divided by 3 leaves a remainder of 2, and that also leaves a remainder of 2. So that's why these operations are fine. Be careful with division. Here's why. Now this is a true statement. 4 and 6 leave the same remainder when divided by 2, which is 0. But you could say, hey, this is really 2 times 2, and that's 2 times 3. So let's cut out the middleman and simplify. Let's divide by this 2. Remember, don't do division. And you get 2 is the same as 3. 2 is congruent to 3 mod 2. Whoa, that's not true because this is a remainder of 0. That's a remainder of 1 when divided by 2. So bad stuff can happen when you divide. Why did this happen? Because the thing you divided by was related to the mod. If they're not, which I won't go into, then you can actually divide, but let's not get into that. All right, so let's use mods to simplify this problem. So here's the idea. This looks really scary. We're going to take this huge tree and chop it down. So we're interested in the remainder. So this is basically, what is this congruent to, right? What is this congruent to? Mod 3. So we're going to chop all of this down till it gets easy. So we're not going to multiply this. What is 43 mod 3? What's the remainder? So 43 divided by 3, that's going to be 42 plus 1. So this is really a remainder of 1. Now this is not, 43 is not equal to 1, but it's congruent to with respect to mods, which is why they're so awesome. So that's it. We've replaced 43 with the 1, but it gets better than that. What's 2,405 divided by 3 in terms of the remainder? That's a remainder of 2. You could either divide it, which is, it's going to be 3 times 800, right? 2403, a 2's left over, or you can use the divisibility by 3 rule and sum the digits, which is going to be 11. 11 divided by 3 leaves a remainder of 2. So we've simplified that down. What is a 2 mod 3? Well, we're just going to leave it. That's already simple. 57. So this looks, of all these terms, this looks like this is the scariest. What's 57 divided by 3? The remainder is 0. So this is 0 to the 103rd. So that's garbage. So actually the problem becomes 1 times 2 minus 2, which is 0. So that's why I like mods so much. Rather than doing this, we shrunk everything down, like we chopped the trees down, and then we computed very easy things. So the remainder when you divide this by 3 is 0.